Are you awake? We're getting into the last stretch, and we're going to end this strong. We have a couple more panels and a couple more discussions going on. We have an upcoming fireside chat, and this is about guidelines for AI robustness and security. We will have 3 speakers and 1 moderator. All right, so why don't we call up Ms. Heather Frase, Mr. Marc Abrams. I'm sorry if I mispronounced it. Did I do it right? Oh, no, I'm sorry. Frase, pardon me. Mr. Marc Abrams and Mr. Dave Epperson and moderator Sheree Zhang. Come on up. All right, let's do a quick little, just while they're all getting settled in here. You might want to need one of these. Grab that. Okay. Yep, there you go.
I don't trust myself.
So, Ms. Heather Frase is a Senior Research Fellow of Standards and Testing, Center for Security and Emerging Technologies. She is a PhD Senior Fellow at the Georgetown Center for Security and Emerging Technology. Mr. Marc Abrams is Chief Technology Officer of Harmonia. He has expertise in various technology trends, including artificial intelligence, machine learning, optimization, statistics, and more. Then we have Mr. Dave Epperson, Chief Information Security Officer for H2O AI. He's obviously the Chief Information Security Officer at H2O, focusing on cybersecurity, governance, compliance, and strategic solution development. He has over 30 years of experience in military and government service. And our moderator for the panel, for the fireside chat, is our colleague Sheree Zhang. She's the Senior Product Manager of H2O AI. She has recognized for significant contributions to responsible AI practices. So let's give it up to everybody here, and let's have a good chat.
Quick testing. Awesome. Well, hi, everyone. I'm so excited to be here today with my fellow expert and colleagues. We'll be talking a lot about kind of robustness and security. This has been a hot topic, especially with generative AI, so we're excited to kind of dive deeper into this space, get some insights onto lessons learned, use cases, testing frameworks, and best practices. So with that in mind, maybe I'll start off with kind of a general question. Stepping back from robustness and security specifically, but what are some use cases that you've applied that are really effective in terms of using generative AI, implementing it effectively, or even one specific use case that you're looking forward to implementing?
Okay, so at Harmonia, we've tried to help our employees and use generative AI internally in one case, because we had to look at all the issues about safety and bounding the inputs and outputs and other issues about it. But, you know, the issue had been increasing numbers of cybersecurity regulations, and each employee had responsibility. So we basically used Gen AI and a RAG implementation to take our, cybersecurity policies, which were, very controlled documents that employees had to go through normal training on, and basically convert that into a chat application that they could use, on the spur of the moment when they had questions about it. So in that case, we have, when they get the answers from it, it basically refers them to the fact that they've got to look at the original sources, and the sources are referenced there and not to depend on the summarization. So it really acts as a way for them to quickly get responses back about that. And, we had to test it in certain ways, like, for example, to make sure somebody can't use it to ask what are ways of attacking, our infrastructure in the company, because it has all the information about cybersecurity policies, other things like give me a summarization of a good cybersecurity policy, because they're, going to go off and start a company and they want to save themselves the effort of figuring that out. And there's other issues which I'll touch on, and use this as an example as we go through the other questions.
Is it on? Okay, good. I am probably the most pedestrian user here. I really use it to just organize and refine my content a lot. I find that I still speak DoD, and that's not the audience that I'm speaking to, so a lot of times I just use it to remove DoD and make it sound a little bit more normal. I love using it to help make sure all my bullets fit on the slides. I mean, these are really boring, but you might find there are a lot of people doing this. The more probably exciting thing I'm trying to do, Patrick discussed briefly the AI Incident Database. I have a significant effort analyzing what is on that. It's non-trivial because it's highly context dependent to understand the harm and what the impact is. So I have a effort ongoing, not done, we'll see how it goes, trying to use an LLM to help me extract information that's relevant to me, and it just can't be done with off-the-shelf LLM.
Let's see, I think the best thing I've done since I've been here was to take all the documents that we had, the new EO, the EU, the GDPR, and all the things that we have to be compliant as a global company. And we have a great framework that she's worked on for quite a while, and then try to complement that with an actual compliance kind of policy document, so that when the DoD or .gov says, are you going to meet the requirements, are you going to meet the standards, I can say yes to the United States, the UK, EU, and go on along. And then as new documents come in, we can use like that diff that you saw to say, oh, there is a difference, how can we be compliant to both, right? Or what we're going to take the higher standard so that we either exceed or meet. So I've been using that quite a bit.
Yeah, amazing. It sounds like all of us have dabbled in the generative AI space or actively using or looking forward to using it. Maybe the next question is, we hear that generative AI is often referred to as a black box type of system. This was mentioned also earlier today. Can you draw upon any previous work or examples where you had worked on a similarly complex system and had to build a sense of trust, transparency, reliability in that other complex system? And are there any approaches you learned during that process that can also be brought into this generative AI context?
Yeah, I think, so we have worked for probably 10 years using other AI methods, primarily with DoD. And, you know, a lot of the issues there were about explainability and as well as validation of the models itself. And building trust with the users in part, I think, was to recognize situations where they really weren't ready for an AI solution. And we might have to go backward, not backwards, let me rephrase that a little bit. If you think about it, the AI field kind of started out decades ago as search, right? And there were search algorithms. But search algorithms bleed into other areas like optimization and genetic algorithms and others. So in some cases, we looked at using integer programming or optimization models or other things because they were able to get users familiar in accepting for a machine decision aid. And when that basis is established, then they're more ready to be able to look at having other AI technologies used and brought in. I mean, the validation for it is a huge issue when they're used for something that's mission critical. So the base work that we've done is really to start with a foundation of things that were easier to validate, like in the optimization field.
Okay, so a little bit about me. Before I switched into the AI machine learning area about 10 years ago, I was primarily an operational test and evaluator and a test designer for the Department of Defense. I looked at major military systems, so these are your big ones. I did mostly radars, command and control, and missile defense. So not only you're talking about understanding one system, but how those systems interact with other systems. These, from a testing perspective, can be equivalent to a very complex and black box. Sure, there's foundations that we know, but once you put them in operational conditions that have a lot of variables going on, there's a lot of things you can't control and understand. So from my testing perspective, I think culturally we've been dealing with black boxes for a long time. I would also point to the medical community. Each one of us is a black box. Then if you look at all of us black boxes together, we're a lot of black boxes, yet we still have progressed in medicine testing. We understand basic principles, we move forward, and we have some trust in our medicine. There's always issues, but we have basic trust in medicine through that testing of black box systems. I don't fundamentally see a big difference with AI. In DoD, though, the evolution of our systems is not as fast as we're seeing in AI. We have actually gone from like complicated black box to more complicated to more complicated to more complicated, right? The first radars were really simple. Now our radars are airborne. We have multiple radars interacting and fusing data together. And they have their own multiple AIs and machine learning systems separate on each of these military boxes or platforms. So I think I leveraged some about, like he says, about stepping back. Part of it is about not going too far too fast. Look at incremental progress with your black boxes to what people can be comfortable with and trust, and then add more. And it's also critical to have experienced users. I think that's part of trust. In the military, you trust, every system's kind of quirky. You learn that if something's coming up over at this angle here, and it's this type of target, you may not be able to see that. You learn that historically through use. And you have experienced users mixing with inexperienced users who kind of teach them when things are quirky, when things work well. Trust comes from familiarity and knowing specifically when not to trust. If you know when not to trust, you tend to trust.
Yeah, I think I'll just echo, like, when I was the CIO of CISA, I think it was called MPPD at the time, SolarWinds hit. And my ops and security guys came to me and say, hey, man, we're seeing different behavior. And it was the middle of COVID. And I was like, everybody's working from grandma's house. Of course they're behaving differently. And I didn't trust the data because I had no way of interrogating the data and doing due diligence to trust the data. I think that's where AI has come a little bit further along that way. But I still think the first thing you have to do is measure, right? And I know we put out a FITARA 2.0 is probably coming out here soon. And I was one of the guys that used to want to strangle the FISMA scorecard because it was 26 criteria that were subjective, and we had certain agencies that we knew were blood red, but because they accepted all the risks, they were green, right? So I think there's something about knowing where you stand. So I think what's going to happen is very, very much like the FISMA scorecard, we'll end up with an AI scorecard. And I think at that point, you're going to learn how many things you didn't see because we're finally measuring for lack of bias and drift. You're measuring for accuracy and robustness, and you're trying to be somewhat explainable. There'll be more criteria, and I think this guy just showed all the really cool stuff that they're working on that as well. But the cool thing I think is a lot of that's math. It's less subjective, so I'm relatively hopeful.
I'm excited for all this optimism. There's a lot of things that we could learn from historical complex systems that we can now bring into the generative AI space, and it's really exciting, and I'm excited to be part of this journey. The next question is about more on the security side. So we kind of talked about how we already are, a lot of companies, a lot of organizations have implemented machine learning models, albeit the predictive models at the moment more. What are some of the additional concerns or security concerns when it comes to generative AI models that are maybe different now from predictive models?
Yeah, so actually I'll return to the cybersecurity example that I gave. So one of the security concerns, of course, is the documents that we're using as input from it. So we have carefully vetted policies that are controlled, as an ISO organization, and so we're pretty safe with those. But now the idea is that we get security indicators from different sources. Some of them come from, encrypted files that were given from, DoD or CISA sources. And so those seem pretty safe to incorporate, but then there's other information too, and we'd like to dynamically incorporate that as well. But now the question is, if we do that, there's no validation for what we've done. And some recommendation that might be in there might, bias what somebody does and they do the wrong thing in that situation. A second issue with that is going to be the time scale too. That threats are evolving and their techniques evolve too. So now what our problem is we've got policies that were based on an earlier time, but people are changing the ways that they do their attacks. So what do we do with that too? And then another issue with that too, of course, is known problems. Language that's used, if that gets in, that's an issue for it too. Is it going to affect, the output that we have? Another area as well of that too is just securing the software infrastructure that we use. It's like a supply chain problem again. You know, how do we make sure the SolarWinds was a great example? The attack was on the build chain in the process that was used. So anything that we have as an application is created and deployed some way, we've got to make sure the same security measures are there as well.
So my view on this is largely informed by the AI incident database, and where I see security and harms popping up in real incidents tend to be from a variety of places. Some have to do with actual training data being accessible, and especially sometimes organizations go in and they fine-tune a system with their personal proprietary information, and that can be accessed. I see issues where people don't realize that like the pipeline that needs to be secured is a little different now and maybe a little bigger. Yeah, and so they're not actually securing all the relevant pipeline anymore. The other thing is they fail to, they tend to underestimate the ingenuity of humans to mess things up. Just simple things like people go in and seem to have the ability to change settings. I don't know if it's considered security, but there's like when the people put the orange cones on the cars. I mean, whoever thought that was creative. So people, when they have the intent, will do these very creative things. And I think the best you can do is probably monitor for some of those, yeah.
So for me, I'm an eclectic kind of guy. I spend a lot of time at Fort Bragg being an asymmetric threat guy. And I'm a geek because I grew up in Tokyo. And I was remembering we had this thing called warp speed, right, Chad? Yeah. So warp speed was to try to get the COVID vaccinations out as fast as we could in a secure manner. And NSA was doing a lot of things, and so was others. Everybody was trying to play ball with this. And one of our politicals brought me in. He said, I just want you to listen and tell me what you think. And I'm like, you got 1,000 people and you're smarter than me. But then it hit me, there's all kinds of part of that supply chain and pipeline. And the first thing I thought was, I'm going to intercept the barcode readers, and I'm going to change, when they click, that 1 becomes a 4, and that 4 becomes a 7, and now all the R&D is screwed. And it didn't cost me very much to intercept a package on someone's desk. So the pipeline is very, very detailed. So you can't just be in the cyberspace, it's got to be in the physical space. And I really think that there's a lot of things that you can do. But industry can innovate much faster than government. I spent 30 years playing government, and now I'm starting in the private sector. But you can't do it without the public sector. You just can't do it. It's too far-reaching. And one of the things I like about CISA, and one reason I stayed so long, was if you have a public and private partnership, that's what's going to take to get AI where everybody has confidence in it and starts to trust it. And that starts with measuring it. Right? That starts with saying we're going to know everything we can know in some AI scorecard that no one's going to be happy with, because that's step 1. Sorry, guys, it's step 1. And then we'll improve that scorecard. And then we'll drop the subjective stuff. And we'll build and we'll share. And it's not that the blame and shame stuff, that's wrong. What really is, they have to be able to volunteer. CISA has only one sector that is obligated to give data. The rest volunteer it. So if some energy company gets hit with some vulnerability, they call us or email us, and CISA us, sorry, it's been a while. We will turn around and inform the entire community that has the same possible vulnerabilities. We probably need to do the same thing with AI in some manner. I don't know if that's a CISA thing or whatever it is, but I think it's something that is going to be required in order to keep up with the pace of the adversaries coming at us, especially the state-run adversaries.
Yeah, amazing. I guess robustness now also plays a part hand in hand with security in kind of allowing for wide-scale adoption of AI. What would a robustness test for generative AI look like? What does that include? What are some of the considerations, maybe at a higher level for now?
So I'm going to give a little bit different maybe take on robustness after thinking about this for a while, because the normal way to think about it is just within the narrow bounds of AI. We need to make something robust. It's a Gen AI solution, so it's got to come up with answers for a wider variety of inputs for it. But if you look at it at a much broader thing, we work in the public sector, so all of our clients are, large government agencies, and they have, the public laws that they're implementing, whether it's agriculture or immigration or other areas like that. So I think that the view that needs to be taken to get to robustness is a little bit like what, and I believe it was DHS that came up with it, with that model of build security in. And so they go all the way back to the early stage of conceptualization of a solution and the requirements and start with the security in that part. When I listen to discussions about evaluation, they're almost like old days and, well, you were in DOD and test and evaluation. We're going to do it at the tail end of the life cycle. And then it's too late to fix the things like that.
But that's not good testing.
It's not good so that's exactly it. That's what I think the maturity needs to come in AI. It's got to be all of a sudden a total life cycle. And actually the complexity is high to get the robustness because it's got to be integrated into, all the normal agile practices and DevSecOps practices or site reliability engineering and other practices that are used. And I think for teams that are building things, it's a little bit of fatigue because there's already so many regulations that are there and things that have had to be adapted to, and now the AI part is going to be layered on top of that. And so I think that's part of robustness. But good news is, I think, sometimes when things get to a breaking point, it actually really improves things, and that could happen with AI too. So for example, there's now supply chain risk management. So now we have another form to fill out, to document all the practices used everywhere in the supply chain. Well, you need now that for AI too, as I think we all understand, for all the components and the origin of the components that we're using. So then if you do that, the question is, are there ways of applying AI in that situation? Again, it has to be validated, but to be able to help with the management of that as well. Because there's a lot of documentation that's being produced with that too. And so there might be some opportunities to help now figure out how do we make this, the conglomeration of all the different aspects together work more smoothly.
Okay, so I want to defend tail-end testing. No, at least to some extent. It's not truly tail-end if done right. If you're doing good operational testing and test design, you think way before you start doing even your basic developmental model testing, because you actually want to understand what operational needs you have. What are your robustness needs, your goals, in your end environment for that mission or for that use case or task or application. And you need to flow those back so that you're actually testing the right things in development. And then you can understand how things work. And from an operational perspective, to me, robustness is, are you sufficiently reliable? Can you sufficiently operate in the conditions where you're going to need to meet your goals? And that is a very different, it doesn't respond to benchmark testing, to very, discrete measures that you often get in development. They might be some mapping to it, but you need to have that big goal in mind. And also, you need to know when you cannot meet your goals. What conditions do you not sufficiently reliable or robust or explainable, and then you know where not to operate.
Bill is dead on. The only thing I'd add was third-party validation. FSMA was really tough until we had to have peer-to-peer review, and those greens often became yellows and more often became reds. And so I think AI modeling should be the same. We should have a third-party validation of all federal models. As a former Fed that had to testify a lot, I would really be happy if I could have a model that had been interrogated by a third party for lack of bias, lack of drift, and all that. And when I'm getting questions, hard questions from the Hill saying, why did you give that resource to that demographic? I go, I did it because I followed the model, and I also did my due diligence and interrogated that model again. So I've done the best I can to provide an unbiased and accurate delivery of services. And I think that's going to help everybody. The third party thing, I think, is pretty important.
Yeah, definitely. This next question echoes an earlier question from the NIST talk by Patrick, and it's, how do we balance, or how can organizations balance the need for rapid innovation, rapid development, but also make sure that they're complying with needs for robustness and security?
You know, we got wind of these questions beforehand, and this is the one that bothered me the most about it. Because the problem is, it's really hard to figure out how to do that. You can, so with different organizations that we have customers for various ones, we look at, you know, trying to take their use cases and do things to show them how, you know, in my case, generative AI, or my colleague Assad Moini, who's the other CTO at the company, does with traditional machine learning models. But, you know, they can try proof of concepts, but really, there's no shortcut, you know, to be able to get something in, even if it's innovation that's needed. It's just hard because the risk of something that goes wrong with that, I mean, it goes back to the previous talk, it's the impact of it and the risk can be high with that. So it is, they're really at odds with each other.
Yeah, I would agree they're at odds with each other, but I have seen common mistakes people do. I think, or things that they could have done to mitigate some of the problems they see by pushing forward quickly. Part of it is having like an incremental rollout and contingency plans. Oddly enough, people don't have contingency plans for what are they going to do if things just go south. So there's some basic best practices, and they're probably even laid out in the RMF, and I just think people don't implement them.
There are two types of CISOs. The sky is falling, and as long as I know my risk, I'll take it. And I think there needs to be something in the middle, right? I think the risk reward is interesting. We would sit down and talk often about large amounts of data, humans fatigue, they make mistakes. We have a model that's performing at X, we hope it to perform at Y, but do we use it in a crisis because it'll at least give us better than the human response? Those are hard questions, and I think it's more of an art than a science at that piece, but knowing what that risk you're taking is important.
Can I add one thing? There is a class that I think it's a little bit easier to envision this in, and it's when you were using AI to go through data and give indicators to people that there might be an issue that they need to look at. So they're not depending on it. We have one client in the federal sector, and we support an AI platform, and it is basically that purpose. It receives a bunch of financial data, and it looks through to see, you know, does all kinds of analysis, sentiment analysis, other things to see if there's anything that might be an indicator. So if it doesn't do anything, it doesn't hurt, although it may still have a little bit of a problem because it may help people direct their attention to certain things and they may miss something else. So there's still a potential problem with it, but it's not a bad way, you know, maybe in that middle ground that you were mentioning.
You just defined my biggest problem as a CISO in government. You know, I would be short people because of COVID or whatever it would be. I wish I could attenuate saying, I'm going to chase less false positive today and I'm going to log the ones I didn't chase. And then I get another source of intel saying that my organization might be targeted individually. So now I want to turn up my attenuation and chase a lot more false positives. We're trying to do that with H2O so that all these other tools, you can dial it in and dial it back out, because I think attenuation is something we have to all consider being able to do.
Yeah, definitely. With this challenge, I see an opportunity. If it's so difficult to balance this robustness and security aspect, maybe that's an opportunity for us as a platform to help our users be able to do this better in a maybe more automated way or a quicker way or a more painless way for our users. So looking forward to addressing that problem, maybe from a product perspective as well. I did want to also draw on your experiences, especially in the public sector. As researchers and advisors, are there ways that you would recommend the industry better collaborate with government and academia in terms of advancing robustness and security kind of frameworks or measures or tests?
I do think that it's a good opportunity for product companies like H2O to kind of, you know, look for their partners at where are there elements of their product line that could evolve, you know, to support, because any of the, even all of the regulation that applies, whether it's executive order or other, to getting AI solutions used, is a basis for understanding how to streamline in the products from that standpoint. Yeah, I mean, we've also worked with academic departments too in trying to bring technologies in, and I think that's always a good aspect too, but I think there's got to be a balance with that as well. Yeah, I mean, just one suggestion of that, you know, thinking about it, because I've reflected, the conference is great for reflecting ideas. When you work in the DevSecOps world and you use tools like GitLab or GitHub, they have the ability to be able to take security vulnerabilities now and link those back to the code sections and the requirements in a really convenient way in the user interface. So the AI part, I believe, needs to be brought in, and the tool, yes, and they need to interoperate with those tools more than just, hey, we've got our code on GitHub and you can take it out and use it.
I personally would like to see a little more work in understanding how we evaluate some characteristics like reliability with the realization that context is important. So I'm going to back up. If there is, like, you have a prompt, most of your safety prompting now for large language models is you put in a prompt and people look at the response and they decide it's good or bad, or sometimes there's a Likert scale, really good, right? It is all high variance though, because each evaluator is bringing not just their personal experience, they're bringing this experience of their society, their part of the world, their culture, and their subgroup. So they're not invalid. It just means that those results are harmful to some and not to others. So how do we handle that? How do we decide that is a safe system? How do we measure and adjust and take out those nuances about context so that we can know, once again, when to use and when not to use the system? What is actually safe if it's so context dependent?
I think AI has become a forcing function for government. And what I mean by that is, you know, I sat down with some old friends in different parts and agencies that I won't go into, but all of a sudden, if we have a dislocated civilian model, we know that these dislocated civilians are going to act in a certain manner, that actually matters. And maybe that matters when the Ukrainians are going into Poland. Maybe that matters when the southwest border, or like Andrew got to work for 6 months when 10,000 Afghan refugees went to El Paso. But it talked about movement and dislocated civilians. That touched State Department, it touched a bunch of different places, but all of a sudden I had a friend of mine call me from the UN Food Security. He's like, man, let me see that model, right? And I think what we gotta be careful of is, yeah, that's exciting, but it's gotta be accurate, and it's gotta, that robust piece, it's gotta be really good at this, but I think there's gonna be some really forcing functions of actually making pieces of government come together and talk. I mean, one of the biggest frustrations we had at DHS was we were pulled together to share information. And it's still a struggle there. And it's getting better, but it's still a struggle. So I'm hoping this helps a little bit.
Amazing. Yeah, I have this red light blinking at me telling me we're at time now. But before I check in with Tom, there's a question, I guess, for the panel.
We actually have a very good question that applies to, that'll be for the entire panel, and it states, and this is related to threat actors outside the United States. Can we please ask the panel where they feel the United States stands in terms of AI tech applications within the military and homeland security versus China and Russia?
I'm not answering that question. No, I think you'll be surprised where the U.S. is. I think it really is subjective because what we're doing with AI and what they may be doing with AI is quite different. But I think you'd be proud of your government that they're doing a lot of due diligence to be ready for it. And I think I should probably leave it there.
I would take a sidestep. I think there are other threat actors that we're not necessarily thinking of. I am really worried about transnational criminal organizations. They have a lot of money. I mean, we often think of some people and organizations or countries potentially being limited by their use of AI because of their funds. ECOs have funds, and they have a big will, and they work on a return on investment model. So this seems like an obvious place. So I am worried about that threat actor, and I would like to hear more discussion about that personally.
The only comment I'll make is we have worked with some organizations in DoD about document security. And to echo what you said, one of the biggest worries was organized crime and the amount of money that they have to be able to spend. So in terms of being able to attack, AI-based solutions or use it to get information, it is a big concern. Like one use case was agency, they do it manually, but they do a distillation of documents for another customer within DoD on a topic. Request is actually insider threat or somebody else that represents, an entity that shouldn't have the information, and they've just spent taxpayer money to come up with a distilled answer. Well, now we bring GenAI in, and, unless the safety level is there for the solutions, people can have a field day with that.
That's it.
Amazing. Well, before we break, I did have one quick, short, last question, kind of forward thinking. What is a growing area of generative AI, maybe in a couple sentences, that you're really looking forward to?
For me, it's breaking the problems into categories. So, for example, for us, I think we feel there's 3 categories. One is things where the source documents are straightforward enough, like our cybersecurity, that you can build a successful application. The second one is where you have a set of documents and there's dependencies between them, for example, in definitions, like those proposal examples. We've used tools like that, but we've tried these tests in some proposals just asking what the definition of offer is, where you can have contractor teaming agreements and small business and social economic categories. It's very hard to get the LLM to give you the right answer. And then the third one is I think that there's a category of problems where there's a concept that needs to be understood, quote unquote, understood by the AI to be able to answer. And you really want to evaluate whether the model understands those higher level concepts with that too. And that's the hardest of the 3. I mean, that's just our classification, but I think some research along those lines and being able to figure out what works helps guide people where they want to target their efforts first to get things to production.
I may be a little less practical. I've seen that there's some interesting work out now where they're coupling large language models with robots, and now the robots have a lot more functionality. Now, this is beginning stages. Oddly enough, I'm excited because maybe we can have more useful and flexible robots, but because of my interactions with the AI Incident Database, I'm also very scared. Because in general, it's the physical systems we are seeing a lot of harm coming in. So if we couple potentially this unpredictability and probabilistic nature of LLMs with actual physical systems, I'm concerned, but also, I do want my really good pet dog that I don't have to clean up after.
I guess I'm just really excited. Part of the reason I retired early was to get into AI and really get a lot more done than I was able to do in the Fed, and maybe come back later as a Fed, I don't know. But the reality of it was, I looked at when the Afghan refugee thing, and Andrew calls me and says, man, I got 4 metric tons of diapers, man. I'm like, oh my God, man, how did you know to plan for that? And all those kinds of things. But looking at that diff tool and seeing a policy change, taking the emotion out of, let's say, an immigration change, more or less, doesn't matter, that will affect physically the world. And we now know where we're going to put the porta pots, where we're going to put the healthcare, where we're going to destroy 4 metric tons of diapers, right? So those things have real world things without any. If you don't plan for them, they usually cost double. So I think there's a lot of cost avoidance and understanding your risk but up front, everybody get ready. The next year or so is going to be understanding what your risk is, because you're going to start measuring. And then we will, with a public and a private partnership, start working through pulling those down and trying to make them better. I think it's going to follow very similar to the FISM model we had years ago. I really do.
Well, thank you all very much for your time today and your expertise. I'm sure the audience knows how to reach you. Thank you all.
Thank you.
All right, let's give Heather, Mark, and Sheree and Dave another round of applause for a very great talk. Thank you so much. Okay, I'll grab this. Okay. All right. We are now entering the last leg of this awesome GenAI world in Washington, D.C. We are going to have another panel discussion, and this is about the hidden challenges of private GenAI deployments. And joining me here on the stage will be Vamsi Dharmaji. He's the principal consultant of Ekin Solutions. We'll also be having Mark Lockerbieler from H2O, he is a senior principal solution architect. And moderating this panel will be our Kaggle Grand Master, Rob Mulla. So just a little bit of them. If you guys can come on up, if you're hanging around here somewhere, awesome. Mark? Megan's going to monitor. Oh, Megan will monitor. Excellent. Okay, good. We'll have Megan Kirka come back up and monitor in case Rob's place. Thank you so much. Okay, all right, just real quick. So Mr. Dharmaji, like I said, he's a principal consultant. He has over a decade of experience in guiding teams, integrating technology, design, and development. He holds a master's degree in computer applications, and he's dedicated to staying updated with technology trends and sharing his knowledge with the wider community. Mark is our senior principal enterprise architect at H2O. He aims to democratize generative AI by enabling broader creator participation. He has significant contributions in projects and publications in the Gen AI and data analytics space. And Megan, as we introduced before, is just a data science extraordinaire, and she will be hosting and taking on these questions. Oh, and Rob, you're here too, sorry. Oh, he snuck in. And Rob, sorry, we forgot Rob, Kaggle Grand Master, senior principal data scientist for H2O. He's got over 12 years of experience, kind of ranging from hospitality to energy and data analytics. He has contributed on significant projects, including the NFL's digital initiative, and he's got a lot of data science, power engineering, and electrical engineering experience. So let's give it up for the panel.
Yeah, we're going to start with Vamsi doing a demo, and then we'll do the panel. So he's going to get his computer up and show a live demo, and maybe, Rob, do you want to introduce it?
Yeah, so this is a project that we've worked on for a client. I don't know if we can say who, but we're developing a chatbot interface that they can interact with. It's powered by LLM. So it's a real-world Gen AI project that we've been working on. We've created a really strong prototype that uses H2O GPT as the back end. And we've learned a lot from the process. So I think the title of the panel is something about the hidden challenges, because I think we've learned a lot from it. But I think part of the interesting things we've hit is that we've been able to implement new things in the H2O GPT to actually solve that problem. So Vamsi is going to demo us here.
Hey, thanks, Rob. So my name is Vamsi. I work for Ekin. We work with 8 to 9 federal agencies, helping them modernize their applications. So this use case is specifically for NIH. And the scope is pretty broad, but what we're going to demo is one part of the feature, that is the chatbot. So the initial scope was to make NIH adopt AI, where one of the departments which work with their electronic business systems, they had various work streams, including application support, working with policy clarifications, helping with procurement, helping with travel and whatnot. So these are all the use cases, and helping with their finance and budget assistance too. These are all the use cases that we have listed down as part of the phase 1. And although we cannot demo most of the things that we have done, the use case that we have decided to demo here is a chatbot, as Rob said, to support the application support work stream. There are multiple enterprise applications in the organization that the support team currently supports, and they get these common questions among various users, right, asking for the same question over and over again. And even though it is, I mean, they are dedicated to help all the users, it takes out their significant amount of effort in order to support that division, right? So that is where we wanted to use AI, where we want to ingest all these documentation, including, job aids, training, user guides, training documents. They maintain all these documents in SharePoint, which is their enterprise content management tool. And the documents are in hundreds, right? And there are very specific for very specific features. One document could have maybe a couple of steps, the other document could have 100 steps, right? So finding the right document, giving them a summary of what the response for the question they have, and maybe having a reference for the document was the goal for this initial project. And the chatbot should be hosted within the SharePoint. That was one of their requirements, because SharePoint is their intranet portal, so they deal with SharePoint daily in and out, as most of the other organizations do. So for the demo use case, what we have done is, even though we cannot demo what we have built in NIH, so we use some of the publicly available guides for this enterprise applications, which is Assist and Extract. Assist is basically a web-based system used to prepare and submit an application for grants, and Extract is also working on the grants, but basically creating the applicants and also helping them to progress reports and training the grant applications. So this is a little bit technical, but if you want to go deep into the architecture, catch me after the session. And here, so the whole goal was to keep it private. That is the requirement from the customer. So here, what we have done is we have deployed and built everything in their network. They use Azure, so we have used their Azure VMs to deploy H2O GPT-E and expose the GPT-E via REST API using Azure Function App, and then built a chatbot using the SharePoint framework, which is called as SPFX. And then we were able to host that chatbot within the SharePoint and deployed them into their intranet sites, where they can use the chatbot to select an application and then fire away the questions they have. And so that is the architecture here. If I'm going too fast, please ask me to stop. I can stop and make sure that these slides are available. So for the demo, what we have done is, as most of the other demos also here, where they demonstrated H2O GPT-E, we created collections for each application. And this is because to make sure that each collection maintains its own data, which is easy for us to provide accurate answers and fine-tune the customizations for each application as need be, and also for efficient in terms of performance and whatnot, because we don't want to parse all the documents for all the applications at one go, right? And GPT-E also has features where we can, share collections to specific users. Maybe we don't want to expose all the applications to all the users within the enterprise, right? So we want to expose few collections to few user groups, which makes security as easier for us. And if you can see, if the collection there are two collections, and the chatbot, once it is triggered, it would show those two options, and that would be the welcome state of the chatbot. And the user has to select one of the applications to further ask any questions. So once they select the chatbot, the applications within the chatbot, they can ask questions, and it is up to the customer to dictate how the response would be. whether it would be bullet points, whether it would be, and what should the chatbot respond if it is an out-of-context question, right? And also what we have done in this project that we're not able to show here is when we provide a response, we also provide a hyperlink to that document, because there are hundreds of documents and each document is specific to a feature. When somebody, say a user asks a question, the H2O GPT will find out which documents it belongs to and show a summary of the response, right? We also fine-tuned the RAG. We use RAG here, and for RAG, we also fine-tune in a way that if it is more than 5 bullet points, let's summarize the response. If it is less than 5 bullet points, then show the bullet points as is, right? We want to have our response very crisp and summarize only when there is a need, right? And also when we summarize or show the bullet points, we also show the hyperlink to the document because the document would have screenshots and whatnot to help them further. So they can click on the hyperlink and then open the document for more help. And also, right, the response format is pretty flexible in the sense that the customer can dictate, oh, for this application, I do not want bullet points. I just want plain summary. And for this application, I only want bullet points. Or maybe I want both, right? So we have done further customizations, and GPT allows that kind of configuration. So it was a well-received feedback from the customer when we showed this kind of flexibility. And with that, I just want to take you guys to the demo. So this is a sample SharePoint site. Let me zoom in, right? And we just named the chatbot trigger as assistant. The real name we cannot share here right away, but you can imagine whatever name you could give. So the bottom right corner, you see the trigger where you can click on it, which opens up the chatbot, and which gives us options to select which applications does the user has question for. And they can select the application, and then you are in this. When you select an application, right, as a customer, you start a session. And this session knows your context. You can ask multiple questions. It keeps track of all the previous questions and respond based on all the questions you have been asking so far in that session, right? And the way we designed this, each user will have their own session, so their sessions will never overlap, right? You having a private conversation, and that is one of the requirements the customer had to provide the personalizations, right? So that we know what questions are users asking, and to see if somebody's asking the same question over and over again, maybe it's something that to do, we have to fix that in the enterprise application itself, right? So all this feedback has been collected in a way to improve the applications or the experience. So let us ask a question. Now it is talking to GPT, and then it is summarizing the response, looking at all the documents that we have provided. And there you go. So we have a response. And here at the bottom, you see feedback, thumbs up, thumbs down, and we also show the source. And if you ask any question, like out of context, something like that. I'm just thinking of any random question. We usually ask who is the president and whatnot, but yeah. So it provides some generic response, and yeah. So we can start a new conversation, and we can again select another application and then continue. I think in the interest of time, maybe this is it for the demo, and then we'll discuss further. And if any questions on this application itself, maybe we can reconvene.
Thanks, Vamsi. All right. So we got to see a live demo of the solution that this team here built out. And each had a unique role in it. So I wanted to start off the panel. I think we'll do about, 5 to 10 minutes of questions and then see if there's any questions from the audience, because these three folks have actually implemented and installed GenAI on-prem in an air-gapped environment. So they're going to have a lot of knowledge of their experience. So we'll let the audience ask questions. But before we get started with that, I wanted to ask everybody in the panel here what their journey was to getting to this solution, and maybe what their role was within the team.
Yeah, so my role was as a data scientist, and this project was really interesting. I learned a lot, especially since working with these type of models is sort of different than the typical data science process. A lot of that was with experimentation. So we spent a lot of time making sure that the responses to the questions worked really well with the specific data set we were working with. So we had a specific set of documents that were formatted in a sort of way that they went through instructions of how to do things in the software. And the data scientist role really was set up those experiments, test different models, and then a lot of time spent with prompt engineering. We're still opening up the possibility to do fine-tuning of the model in the future, but we've found really good results just from tuning the prompts that we fed through GPT-E. And yeah, that was a lot of my role.
Hello. Yeah. So my role was I'm a solution architect. I was always building enterprise applications, right? So even though I worked with machine learning, this is my first encounter with AI. And I was nervous to begin with because I knew a lot of how to build an application, but how to use and integrate AI, I thought it was very challenging. But when working with Rob and Marc and the way H2O GPT-E was built, it was very simple. It was not that difficult. So my role was essentially making sure that my primary role was to make sure we build the chatbot and deploy that on the SharePoint and build that REST API. And also I was working hand in hand with Rob on how to pre-process, make sure that the documents are in the format that we can ingest. There were some challenges. I know Rob and me, we worked together and then see, how we can mitigate that and whatnot. So I was working on partially on the prompt engineering and then basically primarily working on the integrations.
And hello, okay. So I'm an enterprise architect. My role was to make sure that we did all the proper planning up front, and we were able to have the right resource group in place. I was onboarded as the Azure administrator, so I'm managing the whole environment. I would keep the system up and running for these guys, ask them when they're not using it to save some money. We turn it down, turn it back up every day, 8 a.m., 8 p.m. Yeah, my job was to get the software deployed, get the new releases deployed, work with those like our experts like Tom Kay in the back. Thanks, Tom. Yeah, that's the role. So I'm sure there'll be plenty of questions around that.
Thanks, everyone, for introducing yourselves. So maybe just to start off with you, Marc. Can you tell us about the installation? What was unique about this? I think this is probably the first time the team had done this. So maybe just a little bit about that and what was specific about H2O GPT-E that helped with the use case.
Sure. Everybody knows this is a air-gapped or non-internet-based, totally private deployment. What comes with that is a local model hub. So in our architecture, we bring not only the software that we deploy into the infrastructure, But we also bring the LLM or LLMs that can be set up through an inference server that we also provide, in this case, VLLM. And so the challenge here was really to start early with the Azure cloud team at the customer. Don't assume anything. To start early with the security team. Do not assume anything with AI. I've been doing this a very, very long time, and everybody's building their policies and standards and rules, and the roadmap's not there. So it's getting there, and you're pretty much building it on the fly. So we met early with the Azure cloud team, made sure that we had the GPUs available to us when we were ready to deploy. As an example, we met early with the security team. We shared our images with the security team. We shared the models we were going to use. So from a planning perspective, no surprises when we deployed. We deployed the same day. We deployed the software to scan our server. So our server gets scanned every single day from a security perspective, initially and every day. No surprises. So what we wanted to do was get out in front and meet with the owners and get the planning done. The other thing is we had the local model hub, the local repository for images, and we also needed to make sure that we adhered to the agile architecture that the customer wanted us to deploy. My example is Kubernetes. And this is a pilot, and so we can think of it as a prototype, a pilot that could turn into the initial prod. So the beautiful thing about this deployment and any H2O GPTE deployment is we will be able to scale this out. So this initial pilot could be our initial prod, and then over time we can scale. So those are the things that I think planning, bringing everything in-house, making sure we understand their rules, don't assume anything.
Thanks so much, Mark. Now, once that installation was complete, Vamsi, you actually built the integration into SharePoint, right? So can you talk a little bit about maybe what the process was in embedding the large language models into the government SharePoint environment?
Sure. So the challenge was, to start with SharePoint, because the end goal is to expose a chatbot that users can interact with in SharePoint. And so what we have done is, as GPTE has the REST API and JavaScript library in their roadmap, it was not readily available at this point. So what we have done is we built a facade using REST API and Azure Function App, and in Python. So we written that API, exposed that API, and used the SharePoint SPFX framework to build the client chatbot. And with the LLMs, I think the credit goes to Rob, where we have chosen the right foundational model. We have worked with multiple foundational models and finally found the foundational model that worked the best. And the second thing was the documents. So the documents had a lot of screenshots where when we ingest them, we were reading the text on the screenshots. So I think Rob did a great job in parsing out in a way that will not happen. And we built a metadata around all the documents, which was help us to provide hyperlinks to those documents where we have created the response from. So I think those were some of the things that challenges that we have encountered and resolved.
And I remember when we were talking, you actually modified the output of the large language model depending on what the initial output looked like. So if it was a lot of long list of bullet points, then you modified it. So you're actually kind of customizing the output based on what your business audience is requesting as well.
Yes, you're right. So when we had multiple demos, so in one of the demos, we realized that the documents that they have provided had a long list of steps. And I think we worked as a team where I think it was majorly done by Rob, where we used, decided to go with RAG Plus. And we did summarize, and but sometimes the summary is not as readable, right? Because if the response is just 3 steps, making that a paragraph might not be a good option. So what we've done is we updated the RAG prompt where the RAG will decide if the response is less than 5 bullet points, let's show the bullet points as is, because that is in a better user experience. If it is more than 5 bullet points, let's summarize and then show the source of the document so that they can go to the document and then, get more help.
Yeah, that's interesting. And Rob, so obviously you mentioned that you picked the best large language model, and you're also kind of deciding the RAG plus parameters. So can you talk a little bit about how you ended up picking what you did and any challenges?
Yeah, so we tried first using one of the Llama 2 models, and it performed pretty well, but there were some edge cases. A lot of this was sort of experimentation, finding edge cases where the results weren't optimal, and then testing to see how we could improve those. And that Llama model was performing suboptimally in a few cases, so we switched to using a mixed-role model, which ended up being a lot better. But I think one of the nice things is because we were using H2O GPTE as a back end, it really wasn't like we had to use a whole new API and reset everything we had already set up. It almost was just a drop-down menu for picking a new model. And especially with open source models coming out at the rate they are these days, anytime we have a new model, we have the opportunity to plug it in, experiment with that, pending approval, and use that. What we came to with RAG Plus, so RAG is being used to query this vector database with all the documents that we had, with all the different user guides. And what we were finding, what Vamsi was alluding to, is some of these documents had pages and pages to answer one question. So the way the vector database works is it takes these large documents, it chunks it up into smaller chunks, and then when you ask your question, it's querying that vector database to pull out the relevant chunks. This worked 80% of the time. But when we ran into situations where the answer to the question was longer than those chunk sizes, the question may or may not have all the steps needed. So we brought that back to the engineering team, and they built in a really nice enhancement into H2O GPTE RAG Plus, where the model is actually queried iteratively and summarizes each of the responses of the various chunks, and also keeps in order the different chunks of data as it's building its response, and the response quality is a lot better. It comes at the expense of a handful more queries to the database and calls to the LLM, but for our use case, it really improved things. So those are just a few of the examples of things that we ran into and improvements that came out of it.
Thanks. So just to kind of recap, you were able to install the GenAI software on an air-gapped environment, integrate into SharePoint, and also customize the output based on the audience. How long did this take?
One day. No, I'm just kidding.
Well, we've had daily stand-ups and a weekly meeting. What we were at about 3 or 4 weeks, but that doesn't mean there's a lot going on. That the prompt engineering, you should probably answer how long did that kind of take, because we did a lot more than that.
Yeah, I think before even we had access to the documents, we did like a proof of concept, which was using Marc's own private lab, and it was fairly quick. It was within a week's time we were up and running, right? because everything was there, and then we had to do some feasibility checks before even we reach out to the customers that this would be the proposed solution. And once that was a go, I think because of all the processes that we have to follow within the organization, it took I think a couple of weeks. And then the fine-tuning of the RAG prompts or gathering more documents was an ongoing process because it was in a good feedback loop. So I think that's still going on. So I think Mark would write. It would take a couple of weeks for us to get it up and running within the organization.
Oh, that's pretty fast, though.
Yeah, and I think with most things, when you do it the first time, it's a little bit slower, and we're still iterating, working with the client, and trying to make things better. So there's still work to be done, but from what we've learned, I think every installation going forward is going to be that much faster.
I just want to add one more thing. The demo that you guys saw, that is replicating what we have done. That was done within a couple of days.
And I'd like to add one more thing real quick. These guys are amazing, and so is the H2O team, the engineering team, the DevOps engineering team. They were there right with us. They pushed the system to the limit, and they asked for new features like RAG Plus. They got turned around. We got those redeployed overnight. They were back at it, iterating and pushing the system. So these guys were awesome.
That's pretty fast, I would say. Well, thank you so much for telling us a little bit about the experience. And I guess, Tom, if there's a question, maybe we could do one question.
Yeah, we actually, in this conversation, a couple questions were already answered, but I think the only question that is here is, when you were breaking down all the different phases and, in the building, which one of that phase, or of those phases, was where the biggest challenges lied?
I think it could be different for different work streams, but for me, it was the document ingestion, I believe. Like the documents are of different types, and few documents were specific, and few documents were very broad in terms of the information that they had. So I think that would be the most difficult.
Yeah, I think the issue we're having with the RAG chunks and the context length limitation of some of the models we were using, that was an issue. And then the development of RAG Plus and a few other things that really helped out with that was fun to see a good solution come out of it. I also think that's a problem that's going to become less and less as more open source models are coming out that have longer context windows. So yeah, that would be it for me.
And just for me, I needed to make sure that we had enough RAM in our GPUs, okay? So we really needed to just make sure that the infrastructure was set for the new model that we chose.
Well, thank you so much. I think we're out of time, but thanks, and I'll pass it over to Tom. Thank you, guys.
All right. I think there's going to be a picture.